This video will focus on redox reactions, oxidation states, half equations. It's a topic which students tend to find a bit difficult, although the basics of this topic is already studied at GCSE. So let's start like this. Magnesium reacts with oxygen to form magnesium oxide. Balance? Okay. Now, from GCSE, we know magnesium oxide is an ionic compound consisting of magnesium ions and oxide ions. Magnesium loses 2 electrons. Magnesium becomes Mg2 plus 2 electrons. Oxygen gains electrons to become O2 minus. Balance this equation, and that is O2. Make this 2 oxygens, so 4 electrons. In other words, each oxygen atom gains 2 electrons. So this is gain of electrons. So this is reduction. And this is loss of electrons. So it's oxidation. So the first thing is oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So magnesium lost 2 electrons. Oxygen gained electrons to become O2 minus. This equation I'm circling is known as a half equation. Half equation tells me what happens to each reactant or each atom or element in the equation. So we have 2 half equations, one for magnesium, one for oxygen. When we add 2 half equations, we need to ensure that both equations have same number of electrons. So I'm going to multiply magnesium's equation by 2. Becomes 2 magnesium comes 2 Mg2 plus 4 electrons. I'm going to add that equation with this equation. When I add the 2 half equations, I get an overall equation. Magnesium 2 plus oxygen forms 2 Mg2 plus and 2 O2 minus, which is same as MgO. Now, that's simple half equations. The first thing to note. Now let's look at oxidation states. What do we mean by oxidation states? Simply just understand an oxidation state by the number of electrons contributed by each atom when they form a compound. So magnesium is in group 2. It gives up 2 electrons. So the oxidation state of magnesium is plus 2. Oxygen atom can gain 2 electrons to become O2 minus. So the oxidation state of oxygen is 2 minus. So let's summarize it for you then. All group 1 metals have an oxidation state of plus 1. All group 1 metals when they form a compound. Every atom, element, molecule on its own has an oxidation state of 0. All group 2 is plus 2. Aluminium +3. These are when they form compounds. Now, There are now exceptions. So the general rule was group 7 elements like F is -1, chlorine is -1. However, you will notice now that that is not fixed. So let's just give you the general things you need to remember. Okay, so group 1 is always +1, group 2 +2, aluminium is +3, fluorine is always -1. Oxygen is always -2, except 2 occasions. If it bonds with fluorine or if it's a peroxide. Here it's oxygen is -1, here oxygen is +2. That's the only 2 occasions. Every other occasion oxygen is -2. The oxidation state for non-metals changes when they bond to another non-metal that's more electronegative. Let's look at some examples. Why is sulfate ion -2? That's because oxygen, as I said, oxygen is always -2 except when it bonds with a fluorine or peroxide. So there's 4 oxygens. 4 times -2 is -8. Charge of -2 overall. Sulfur must be +6. +6 -8 is -2. Another one, ammonium ion. Hydrogen is +1 except when bonded to a metal, then it's -1. Nitrogen is in group 5, it's -3. 4 hydrogens means +1 times 4. Overall charge is plus. What about nitrogen in HNO3? What's the oxidation state of HNO3? Hydrogen is +1. Oxygen 3 times -2 equals -6. Must be +5 because overall it's neutral. Now, I think this question becomes challenging when questions of the following nature arise. Things like following. Write an equation for oxidation of chloride ions to chlorine. So, oxidation chloride ions to chlorine. There's Cl2 here, make this chloride ions 2. Now the question is, which side do electrons go? Total charge on this side is -2. Therefore, I have to add electrons to the opposite side, 2-. Okay, now how do you use oxidation states to determine oxidation and reduction? So we know oxidation is loss of electrons, reduction is gain of electrons. Now let's look at this one then. Okay, chlorine reacts with bromide ions or with sodium bromine to form chlorine plus to form bromine, plus NaCl. Balance. This is a displacement of halogens from GCSE. Chlorine on its own, oxidation state 0. Sodium group 1 must be +1. Br is in group 7, must be -1 because it's not bonded to something more electronegative. Bromine 0, Cl -1, 0. Now let's make this equation into a ionic equation. 2Br minus bromine plus 2 chloride ions Oxygen now has been reduced because the oxidation state has decreased from 0 to -1. So decrease in oxidation state is reduction. Bromide ion has gone from -1 to 0. That's oxidation because the oxidation state has increased. So if there is a decrease in oxidation state, that is reduction. If there is an increase in oxidation state, that is oxidation. So increase in oxidation state is oxidation, decrease in oxidation state is reduction. Lastly, let's focus now on complex half equations. A simple half equation is like manganate ions oxidize Fe2 to Fe3. We need to construct two half equations. Let's look at the simple equation. Fe2 oxidized to Fe3 plus. Note, if it's oxidation, the electrons are always on the right. 2 plus on the left, 3 plus on the right, add an electron, plus 3 minus 1 plus 2. Now, manganate ions. Manganate ions are reduced to Mn2 plus. Here's the rule. I won't write the rules. You can pause the video to note the as to what I am about to say. To balance half equations with oxygen, the first rule is balanced oxygens. So I'm going to balance oxygens. So I'll actually will write now. To balance oxygens, add water. Actually, before that, the actually more important point is I'm going to balance manganese first. 1 manganese on both sides. I'm going to add 4 waters on the right hand side. The reason I'm adding 4 waters is because there are 4 oxygens on the left. Once you balance oxygen, you need to add H plus to the opposite side. In this case, I'm going to add 8 hydrogen ions here. The reason I'm adding 8 hydrogen ions is because of 4 waters. So the last thing is balance charges. And to balance charges, add electrons. On the right hand side here, you have a total charge of +2. On the left hand side here, you have a total charge of +7. So I need -5 on the left hand side. So I'm going to add 5 electrons. That's balanced now on both sides. Another good example for you. Dichromate CrO72- is reduced to chromium 3+. Okay, to balance this, first thing, balance the chromiums. Add 2. 7 oxygens, add 14 waters. Apologies. Write this properly. Add 14 waters. 14 waters. My apologies. Let me start this again. Let me just start this again. Okay, I'm going to dichromate to 2 chromium 3+. Add 7 waters. 7 waters means 14 hydrogens on the right. Now on this side, on the right, +6. On this side, +2. So add +6 electrons on the left. And there's your balanced equation now. Dichromate plus 14H plus 6 electrons forms 2Cr3 plus 7 waters. And that's the balanced equation. Hopefully that makes sense. Any questions, please ask.